Okay, now we understand exactly what procedures are. They have two important properties. They are values and they have a contextual environment. The combination of these two properties is very powerful and leads to some very powerful programming techniques. In fact, we can say that the whole layered construction of data abstractions that gives a lot of the power to today's programming systems is based on this form of procedure. Okay, so this form of procedure is in fact one of the most important concepts in computer programming. And in fact, it took some time before computer scientists figured out exactly which was the right concept. So this is the one we're teaching in this course. So during the rest of the course, we're going to see a lot of this power. For example, in building the techniques of object-oriented programming. But let me show you some of the power right now. So we can pass a procedure as an argument to another procedure or get it as a result. This is called higher order programming. The term comes from the notion of order of a procedure. So a procedure, all of whose arguments are not procedures, integers for example, is of first order. Now, if a procedure now has arguments that are procedures, we take the argument with the highest order and we add one, and that's the order of the procedure. So passing procedures as arguments, getting them back, lets us program second order, third order, and so on, higher order. Notice that all of these ideas hold just as well for functions as for procedures. Since functions are just a kind of procedure, and in the kernel language, there's no distinction between them. So let me now show you some examples of higher order programming. First example is a function passed as an input. This is called genericity. So let me define a very nice function called map. So map takes a one argument function as an argument and a list, and it applies this one argument function to all the elements of the list and it returns a new list. So case L of nil, then nil. So I do the usual pattern matching for lists. Otherwise, h bar t, then I do f of h and followed by map f of t. Okay, so let me define this and let me show you how it works. Let me call map with an anonymous function f of x that returns x squared, x times x, and with the list 7, 8, 9. Okay, if I do this, I get, as a result, the list 49, 64, 81. Okay, that's one example. Let me show you now another example. Function passed as an output, and this is called instantiation. And you'll see why when I show the example. So let me define a function called makeAdd with one argument, a, and it returns another function, which is an anonymous function since it's returned as a value, f of x giving x plus a. Notice that the function that's returned has a contextual environment, which is not empty. Okay, so let me define makeAdd, and let me show you how it's used. So let me now define a function called add5, which is makeAdd with argument 5. So I call makeAdd with argument 5, and it returns a function which, when called, adds 5 to the argument. And now if I do browse of add 5 to 100, I get 105. Okay? That's a function passed as an output. Before going on, let me now ask a question. What is the order of map? Well, you're giving it a function, which is a one-argument function. Assuming that the function f is first order, then map is second order. Okay? Because it has a one-order function as an argument. Now, what about makeAdd? What's the order of makeAdd? So makeAdd has an output, which is a function which takes an integer and returns an integer. So the order of makeAdd is 2. So both of these are in fact second order functions. Let me now give a third example. As input and output, Let me do the example of the function compose. Compose will take two one-argument functions and return a function which is their mathematical composition, f and g, and it returns now an anonymous function of one argument which does f composed with g, or g composed with f, sorry, f of g of x, n. So what this does, it returns this function here. What is the contextual environment of this function? Well, it has f and g. So the contextual environment contains f and g. Let me now define another function called f new by calling compose. Let me give it a first anonymous function that does x squared and a second anonymous function that does x cubed, like this. Okay? So what does f new calculate? If I do f new of 2, what's it going to display? Well, it's in fact x to the x squared to the third power. So it'll be x to the 6th normally. So it should be displaying 2 to the 6th. And it displays 64, which is exactly 2 to the 6th. What's the order of compose? Well, it has two function arguments and a function result. But the arguments of these two anonymous functions here are integers. Okay? And so the argument of the resulting function is also an integer. So these two functions are first order, and the result is also first order. So the order of compose is 2. Compose is also a second order function. So all three examples are second order. But don't worry, in the rest of the course we'll see orders greater than 2.